if you want to record any of these class meetings, you click on the record there and it pops up over on this side, says, is it okay for someone to record? And I answer yes to everything. Everybody may record every class meeting, including this one. If you want to, it's easier than taking notes by hand. Oh, you know what? I should have mentioned it to those others too. Do you see that new, to me, it's new. There's that AI button at the bottom. Yeah, it says AI companion. And you know that maybe I'm slow discovering stuff, but that's really quite amazing. If you click that AI companion will take notes for you. Everything I say and talk about here will be written up in nice, clean English with nice paragraphs with headers over it, and it'll all be saved and it's emailed to you after class ends. You don't have to sit and write with a pencil anymore or record it with the keyboard. AI keeps up faster with human speech than you can keep up with your fingers. So, I recommend it. I think for a text description, that's better than humans can do. If you're going to take notes by the keyboard, eventually human speech is faster than your fingers. Even a court reporter takes a dictation at a really fast rate, but the AI does better. So take it for what it's worth. If you want a record of what happened here, you can have it in text form by using AI, or what AI can't give you is the pictures, but that's okay. It gives you the spoken word, nicely organized. Okay. The pictures they can't. That's where you have to record the video if you want the pictures recorded. And they'll be up here somewhere, like that stuff. All right. You know, okay, first of all, why am I teaching? Why am I not using up the board? You're going to ask each other sooner or later. You'll ask me. There's a reason. Okay, so the reason is I think I'm the oldest teaching person in this building. I think I haven't found anyone older than me. So I'm the age of your grandparents. You know, here's a funny story. 6 months ago, I parked the car on the street near my house. Okay. And a neighbor lady comes out 2 houses away, runs up to me and says, I know you're a teacher. I said, yeah, that's true. She says, do you teach in computer science? I said, yeah, that's true. She says, my husband took your class 30 years ago. Oh, really? I said, that's amazing. And then she said, my son is in your class now. And so when your kids are born, send them over here. I'll them to enroll in my class. See, it's the second generation already is coming back to see me, which is quite funny. Okay, well, anyways, during a health checkup, the doctor says you got bad nerves. What's bad nerves? I asked him. He says the neurotransmitters don't transmit the data between your body parts and your brain. It's coming too slow. And I said, is that a problem? He says, yeah. Whenever you walk, for instance, your brain tells your left foot move forward, and then your brain tells your right foot move forward. So for you, it's really slow transmission. For normal people, it's 40 meters per second, but for you, it's like 22 meters per second. And you're at risk of falling over because your brain doesn't know how to react to the signal. Okay. So I say, well, what am I supposed to do? And he says, well, try and carry on normal life, but don't stand up too long. Well, what's too long? He says about 30 minutes. Don't just be standing in one place more than about 30 minutes. your nerves are going to collapse otherwise. So I've stopped teaching on a whiteboard. That's the end result why I teach to you sitting down. In case you ever wondered, that's the cause of teaching by sitting down. I taught for many years writing on the whiteboard, but I'm not supposed to do that anymore. Okay, you know what SI is, don't you? That's teaching outside of the ordinary classroom. Okay, and certain classes get to have an SI teacher. Administrators pick the ones with the greatest fail rate to have SI instructors in proportion to how bad students are failing. We have an SI instructor who's actually took this course from me a year and a half ago. She is very knowledgeable and has been through the fire and came out really well trained in assembly. So she's going to make available extra teaching to cover the things that I cover, but I don't have enough time to do it in depth. She's going to carry it out in greater depth. She happens to be with us here right now, and her name is Caitlin. And I asked Caitlin to introduce herself and sort of tell us about what happens when she's going to teach you. I think it starts next week, by the way. They don't teach during the first week. Caitlin, can you tell us something about what SI is all about?
Yes, like you said, SI is for classes with very high. Oh, sorry. SI is for classes with very high fail rates. So it's going to be like offered for free with the tuition, but mine are going to be available on Mondays and Wednesdays from 1 to 2:15 p.m. We don't have rooms yet, so we're going to start next week. But they're basically going to be collaborative study sessions, is how I would describe them. It's not going to be tutoring and it's not going to be homework help, but we might cover material that might be in the homework. And if you can't attend my sessions, we also have two other SI leaders. We have Koa and Sarah, who also have their own SI sessions.
Maybe you can hear better with her. Any questions for her? That's Caitlin. Okay. So her topics, she chooses her topics. I don't have any directions for her. She's been through this before, knows what it's all about. And I suspect her topics will be related to what I cover here first. And then you guys are going to practice it in greater depth so that you can get high scores on those tests that are coming. You have access to the syllabus. I don't sit and read the syllabus to students on the first day. That feels so much like high school. Oh, so I'm counting on you to download the syllabus and read about it. In quick, here's what we're up against. We're up against, am I under the camera? Assignments 1, assignment 2, assignment 3, midterm called concepts, midterm called program, assignment 4, those are programs. Assignment 5, assignment 6, the final called concepts, final called a program. I think I have them out of order. Program, AM. For administrative reasons, I have to switch. The program will come first, and the final concept test will come second. And then Kahoot games are unannounced. Okay, these will have definite dates. You already have assignment one in your hands, and on the last page is the due date for assignment one. And then when that one is submitted, then I'll post two, and when that's submitted, I'll post three. So in short, this is 20 points for assignments. This is 100. This is 100. This is 20. This is 20. This is 20. This is 100. There's 100. And these vary, but they're usually between 10 and 20 points each time we play a Kahoot game. The Kahoot game reemphasizes assembly concepts, architectural concepts. At the end of the year, you have a big total number of points, and then I put that in a curve and see how it comes out. We can discuss that in more details in coming days. Okay. Your programs, I have a help. I grade some, and I have a grader that will help on some of them. Generally, I'll return you a number for each assignment. It's worth 20 points, and you did it perfectly well. You'll be on a list that says your score is 20, or your score is 18, or your score is 10. Okay. You don't get the program back because you already have a copy of that. On this one, you actually get it. You get the original document back with a score on it. Again, this is a program. You'll get your number, but not program back. Same story down here. You'll get this one back. Will be returned to you with a score. Okay. Kahoot is game. It's commonly known, and you answer questions about computer architecture, and the machine keeps track of your score. And usually you can win about from 10 to 20 points by playing Kahoot. But you don't know when it's coming. So you have to come every day, just in case. That's the rest of the syllabus, you can read about it, but that's the one you're probably most interested in, is how is my grade computed in this course. Okay. Let me take a quick look at, yeah. So we're going to start lecture now. Okay. I can't use the whiteboard because of nerves, but that's okay. All right. When we say the word assembly, so I should date this. If you're recording this, you want to play it back. You want to see the date up here. So this is January. This is not a very good marker. Let's find something else. I'm trying January. What is the day? 22. Yes, I see it. January 22, 2025. We are CPSC 240 at 10 o'clock. And we study architecture and language jointly. It's hard to separate the two. And in the title of the course, it says architecture and assembly programming. So the word is architecture refers to, for us, it's going to refer to how the microprocessor is constructed. We'll learn the components of it. For assembly, it means the language that's in most of your personal computers. Because the word assembly is very generic. It includes there's many assembly languages. There are many languages called assembly. They're different according to which microprocessor is present. So this is assembly for the Intel x86 family of processors. If you were to, some modern computers have ARM inside. ARM assembly is completely different. It's you have to take a different class for that one. This is this is not ARM. Okay. So to be precise, we should say you're learning x86 assembly language. Okay, so inside the microprocessor, they're usually about 1.5 inches square in size, and height is 3 or 4 millimeters high. I don't have the height drawn here, but looking straight down on top, 4 mm high. Inside of that, we abstract what's present. I need next. An abstract view would say you have this present. Okay. There's a region where general registers reside. GPR, general purpose registers. There's a section, it's technically called a component of FPU, floating point unit. Those are registers. There's a section called SSE, which holds other registers, and there's a section called AVX. Okay. These three, I don't know why Intel doesn't include that one, but these three are called the three components. Okay, let's do our architecture learning first, and then we'll do assembly. Okay, starting with GPR. GPR contains, the count is either 16 or it's 17. I'm going to call it 16, depending on how you count things. 16 registers whose names begin with the letter R. Name begins with R. Okay, so let's get familiar with some of them. RAX, RBX, RCX, RDX. There is no REX. There's others, RB. No, the RGP, GP. I'm missing it. RBX, RCX, RDX. Forget it. Even I forget. RDI, RSI, RSP, RB, RBP, RIP, and then I think we start the sequence in numbers. R8, R9, R10, dot, 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 R15, and R flags. So, unless I missed one, I don't think so. There's probably 16 here. There's a bunch of that I didn't write their names because it just goes in sequence: R10, R11, R12, R13, R14, R15, then R flags. Those are storage for integers. They're intended for integer data. Now, sometimes programmers can do tricks and get float data in there, but that's not their purpose. Their purpose is to hold your integer numbers. And here's if you're going to multiply two integers, add or subtract two integers, those integers have to be sitting in these registers. Okay. Let's move on, because this is a fast survey of what this CPU is doing. The next component over here, FPU. By the way, we work this semester a lot with GPRs. And it turns out also with that one. Yeah. FPU is floating point unit. It's kind of obsolete. We do not study it this semester. You should simply know that it exists, and it exists to support legacy programs. Old applications that were written years ago still have to run. They need this one. It has 8 registers. Registers intended to hold floating point data for floats. I shouldn't even bore you with it. The registers all start with the ST, ST0, ST1, ST2, ST7. Okay, but we don't study that because it's old. New programs are not being developed that use FPU. Next one over is known as SSE. Okay, this has a hard name to remember. I think it's streaming. S single SIMD extension. Okay. So this is an acronym inside of an acronym. SIMD means single instruction. Multiple data. For purposes of speed, if you had to multiply together 2 integers here and 2 integers here, this one's able to do them in the same machine cycle. You wouldn't have to do one first and then the one after it. We may get to that point, but we probably run out of time. So this is important for really fast running programs. If speed is of essence, this is where you want to put your data, because it can do 2 and sometimes multiple operations in the same machine time, same machine cycle. Okay. Last one, we don't study it, but its name is advanced vector extensions. Okay. It has 32 registers, and they all start with the letter Y. Did I explain back here? Oh, you know what? I jumped ahead slightly too fast. The names of the registers in SSE. Let's put it here. The names of the registers, and we're going to use these a lot, are XMM followed by a number. XMM0, XMM1, XMM2, down to XMM15. Okay, this we'll use a lot. Okay, the AVX has 32 registers with names X becomes a Y, YMM 0, YMM 1, and so on. YM, would it be 31 or something like that? Okay. Their operations here are so similar to these. It's sufficient. If you learn these, you could pick that up in an hour or two someday if it was ever necessary. So we're going to learn a lot about SSE and XMM registers, but this one exists, but we won't make programs with it. Okay. Let's see. Any questions? I should have chat in front of me in case somebody asks about. Oh, geez, class, we got to pause. I see I overlooked something. The administration wants me to take attendance. Wants attendance on the first two class meetings. Okay, here's what we got to do. Take a 10-minute pause. There's a system of taking attendance by Zoom, and I tried it out at home this past weekend. I couldn't get it to work. So we have a backup system. In chat, send me a message in chat that's just your first and last name, your legal name as you're known at this university, and I'm going to copy that and paste it in elsewhere. So just fill up chat. Well, I see all your names coming. That's great. And okay. I normally don't take the attendance ever, but attendance is not for me. It's for those other people. Let's do. Okay, so I'm going to screenshot all your names. And see where you start. Okay, this. Okay, this is. Okay. I can fit about 12 names in one screenshot, but so I have to repeat it probably 3 times. Okay, let's do another one. Screenshot. Okay, that's the second screenshot. Let's go for the third one. I get these off. This goes through Brian. Okay. Maybe this is the last one. One more shot. Mm, um, and this one. Mhm. Okay, yes. Yeah. Mm, mm. That went through Matthew. There's last one's last screenshot. The last group is coming. Okay, so we need screenshot. Okay. Okay, I think we're done. Let's go back to where we left off. That was the overview of architecture and now programming. Your your current assignment, I'll refer to it as A1, has two source files that we can recognize. This one is called, give it a name, geometry dot C. Okay, and this one contains main. Okay, at a certain point, it makes a function call to triangle, ASM. Okay. And this one, the extension over here indicates this one is written in assembly, this one is written in C language. And this one does not have a main, but you'll see soon that it has a place where triangle is named with a colon after it. That's the calling point where this one makes when it recalls to this one. So inside of, let's, oh, one more. Off to the side, disconnected, is a third file commonly called r.sh, but we refer to it generically as the bash file. Okay. The bash file contains the instructions to compile this one, to assemble this one, to link together their two object files, to load the object file, links together two object files to make an executable file. This one is in charge of loading that into memory and starting execution. So in a sense, this is the manager that manages this small system of two files. All three of them together is called a program. Is the set of, in our case, of three. In an advanced case, it could be a set of 50 different files containing source code. Somewhere there has to be a management system, a management file that runs all that stuff. Okay. What's wrong with Visual Studio Code? Visual Studio Code can make these nicely and it will run, but it doesn't make this one. It's all too frequently somebody submits two of these and it says it runs in my computer, but never turns this one in because Visual Studio doesn't know what it is. Okay. I don't care where you build your software, but you have to send me all three. Send me two of them is not good enough. It's not even graded. It's just a 0. That's the common flaw from users of Visual Studio. What's happening is hidden from the programmer. You don't see it all happening. But here, if you write your own set of instructions, you'll see it and you'll know it, what's happening. Okay, so we'll run out of time. Let's move on. The main is like C++, integer main, blah, blah, and declare some variables, double value, output some messages. The handout tells you that it's supposed to output a welcome message. But the key part is that somewhere in here, there's a call, value equals triangle. And then there's some other stuff here about say goodbye. And there's some welcome things up here. Okay. That's the connection between C language and assembly language. It happens right there. Now, when the C compiler goes through this and it finds triangle, it tries to look around and see if triangle is declared down here, but it's not. It's in a different file. You have to tell the C compiler, hey, it's not here, it's somewhere else. And you do that up here. Extern. That's generally called a prototype of the function triangle. So when the C compiler finds triangle here and it's seen it back here, the extern tells it this is not in this file. Don't panic. It's somewhere else. And somewhere else is taken care of by the linker. And we have the linker under our full control back here. We got to get one of these up here so we can see it. I'm afraid we're going to run out of time. You control when it's going to link and what it's not going to link. It's not Visual Studio Code. Okay. I think that's enough on. Well, lastly, how do you if you never programmed in C before, how do you program in C? You write it in C++ and get it debugged, and then apply the C compiler to it, and the C compiler will tell you which things have to be fixed. I can tell you which ones are usually need to be fixed. Include statements. In C and C++ are not exactly the same. They got it. There's different ones. There's things like include stdio.h. Standard input output is a common one in C. I don't think it's a common in C++. Okay, and the IO statements are quite different. IO statements, but the rest is pretty much the same. Instead of C out value, it's printf value. It's easy to pick those up. We don't have any C out CNs, but we have the equivalent in a textual name, a name of a function spelled out. That's what the C compiler will tell you you need to place instead of C outs and C ins. Let's go on to the hard stuff. What I want to do is outline. Yeah. Let's see the clock. Okay. Let's outline the function. This one back here. And make a sort of a generic outline of what an assembly function should look like. Okay. So generic, it can be used in many places. Generic outline. Okay. I use, well, I don't know if it's available to you, but I use a text editor called Mousepad rather than Notepad, but it's okay. You know, whatever editor you've got available. The first thing, if you download one of my sample programs, there's a section at the top bordered by stars, asterisks. This is the open source license notice. Okay. A bunch of words, you copy them out of the sample, change my name to your name, change the name of my program to the name of your program, and you'll be probably good to go. Below that is a bigger section, which is information about this program. Well, this program. So one thing you start off with is information about the author. You look at my examples and see if I put information about me. Obviously, your name, your CWID number, and your email address are key things about your author. Who's your audience? Your readership are other programmers in your team if you're employed in software development. In software development, you're not a lone person. You work in a team, there's a team leader, and after a week's work, your work is reviewed by your other co-members of your team. They want to read about this program without reading a bunch of source statements. There's nothing worse than reading assembly of source statements. Okay, you got to get that information up here. So the author, and then the purpose of this, after author comes something like purpose of this program. What is it intending to do? And we could isolate it to, there's two kinds of purposes, the purpose of the program and the purpose of this specific function. Purpose of program, purpose of function. And tell us the computer on which it was developed. Developed computer. If it passes on to the, if you get promoted in your company to a higher position and somebody new comes in to replace you, they want to know where it runs correctly, what kind of computer was used to develop this and where was it tested. So results of testing. Results, what was it? No, results of testing. Well, language and syntax and dates. Is this program 6 years old? was it developed in 2018? Dates when developed. There's three or four other things I'm drawing a blank on, but we'll look at samples that are posted, and you can see how it's done. When you're replaced in the company, hopefully because you moved on to something that pays higher, some newbie is going to come and fill in your place in the team. That person may be put in charge of code that you've written. That person wants to know this kind of information before getting involved in reading code. Okay. We're going full scale professional here. Okay. Lastly, is this valid or is this trash work? I had a student many years ago who left and was hired. I can't recall the company, but were developing a lot of software. She came back and visited one day and said, on my first day, I was shown to where my cubicle is. There was a computer there, and there was a desk there, and some pencils and some notepads. And I was told that we're working on project such and such. I should get familiar with it. She told me that when I opened up on my monitor, there was introductory stuff like here, like this. And I said, how much? And she said, in paper terms, it would be 60 lines on a sheet of paper. It went for 40 pages. I scrolled through ream after ream of stuff explaining what this program was about before I got to a statement that actually is compiled by the compiler. This is still important. This is important for your portfolio. Portfolio is what you put on a public storage place online, and when you go for the job interview, you say, hello, sir, would you like to review some of the things that I've made? And you pass him the URL, and it looks good, and it looks professional. That's why we're going for a professional style of program to get you hired. You wouldn't believe how many programs I get. The number is reducing. How many submissions I get? No student name on it. No, nothing. I have no clue what it is. I searched for the way to give this an F because this is not computer science material. This is high school stuff being submitted as if this person wants employment. After these about the program, statements about the program. Yeah. There comes a section that's declarations. By the way, a comment is a semicolon on the left side, as you can probably guess already. Okay. Declarations are, well, there's only a few cases of this where you want to assign an integer to have a name. So max equal 40. So we gave a name to a constant integer, and there's one other important one. See if constant. I'm drawing a blank. Oh, well, yeah, of course. Okay, all those functions that are not part of that you didn't build, you're using somebody else's function. We need to declare those. That's why it says declarations. So they come from somewhere else. Extern scanf. Extern fgets. Extern string length. Okay, those all exist someplace in somebody's library, and you want to use them. But the assembler, we don't call it a compiler, the assembler will get bent out of shape if it finds you calling printf and it looks for it and can't find it. This is a signal to the assembler, hey, don't panic. These are someplace else. The linker is going to take charge of putting them all together for you. Okay. There's one special one. This function, which I called triangle, needs to be called from someplace outside of the file where it is. And therefore, it gets to be global. That allows the driver function, the main, to call triangle. It has global accessibility. Those are declarations. The next section is called dot data, and it's preceded with the word segment. Dot data. It holds arrays that have been initialized. Okay. Initialized arrays. We need a couple examples. An array of 4 numbers. Let's go with sizes. I don't know. I made up a name. Sizes. DQ 17, 39, 20, and 6. Okay. That's an array of 4 numbers. Each number has storage of a queue. So on scratch paper, let's explain what a queue is. D, oh, by the way, D is for define. Sizes defines quad words, and there's the 4 values in the array. The array has size. It allocates space in heap space for 4 of these numbers, and you need to know the sizes. So we go over to scratch paper. B is byte. W is word, equal to 2 bytes. D is double, equal to 2 words. Q is quad, equal to 2 doubles. Okay, so that's the abbreviation scheme we'll use all semester. Most of the time, we're at this level. Most of the time, we're making quad words. Okay, and so that's what I did here. That Q indicates that each one of these numbers sits in a cell of size. If you multiply them all out, there's 8 bytes. All right, and it doesn't have to be numbers. We can make an array of char. So my name, DB, those are bytes. Okay, so each letter is receiving 1 byte. That's because of this guy. He's on the list at the very top, and it allocates storage in low addressing memory, typically called the heap area. It allocates space for this and fills it in for us. What's the 0 for? What's the 0 at the end of a string? Everybody passed the data structure. That's the null character that marks the end of a string. Just like in C++ language, all strings have that, or they better have it, or else they're in trouble. The next segment is dot BSS. And I'm not making up a joke here. I have forgotten what BSS means. It actually has some meaning. I once knew, but I have no clue now. Okay. This is for arrays that are uninitialized. Arrays. Yeah. Let's make an uninitialized array. Okay, suppose I need an array to hold a score of all your assignment ones when they're all turned in and then they're graded. Everybody has a score, so we need 35 slots in our array, and they're each supposed to hold a positive number. Positive integer is what positive not important. It's the integer that's important. So I'd say scores reserve quads 38. Okay. The RES stands for reserve or create that much space. Each space is a quad word, 8 bytes, and altogether there's going to be 38 of these, and they're waiting for data to be put in each one of those slots. Okay, so all the arrays that are uninitialized are built that way with RES followed by a single letter that indicates the size of each cell. Could we do something smaller? A word, a number that fits in a word is 2 bytes. That's in a range from unsigned ins in a range from 0 to 65,000. But we could make an array of small numbers in that 0 to 65, 656. I forgot what it is. I think it's an 8. Nevertheless, here is what should we put? Temperatures. RESW 31 days in a month. Okay, that would create 31 slots for numbers. Each number is a 2-byte number, 2-byte integer. We're not dealing with floats here. That's what the W stands for. And we could figure out how many bytes of storage that would take. It'd be 32 times 31 times 2. 62 bytes would be set aside for the array called temperatures. And this one, that would be 8 times 38. That'd be the number of bytes that would be set aside for the numbers called scores. Okay, this is kind of scratch paper. Let's continue developing the program. Okay, this is the place where you can squeeze in what we would call pointers. Let's make it pointer RESQ1. If the array has only one cell, the name of the array is really just a pointer to one cell. So it kind of doesn't make sense to call it an array of one cell, but it makes more sense to say the name of the array is a pointer to a single value. Okay. And someone's wondering how do we use that? To put a number in that pointer, the assignment statement is a move statement. Yeah. So the move, this copies 38 into the memory location that pointer points to. This one up here. It's ready to accept one value. So previously in previous courses, you dereference with an asterisk. but here we dereference pointers with square brackets on both sides. And it's common, it'll be common in the coming days. Okay, any questions? I'm not, my chat's in the wrong place here. Okay, no questions. Segment data, BSS, the third segment and last, and the biggest is segment text. And yes, you have to keep the dot there. I'm not sure why, but it doesn't matter. The dot has to be there or else it doesn't assemble. Okay. Segment text, the first thing you must put is the global function. Triangle, colon, and a colon. The colon is an important marker. That's the connection with the driver function. The driver is going to call triangle, and it will pick up execution wherever you put this guy. And obviously, I guess there's some rare exceptions, but you want execution to begin at the start of the source code. This segment text contains instructions that are going to be executed. The next thing that should happen is general purpose registers have to be shared among many functions. You can't create new ones. So did I put it back here? Let's see if I see driver function. We're talking of these here. The driver function may have data in those registers that it expects to use. But if your function comes along and overrides it, then when driver resumes, it's lost its data. So we're courteous programmers. We back up the other guy's data at the beginning here. This right next, the next section is backup. And you do it by lots of pushes. Push on. I'll stop writing these because you have to go through all 16 of them. Push, or, etc. Push, or 15. We intentionally omit RAX from this list. I don't want to get that detailed, but there's a reason why we intentionally miss it. It's used for parameter passing when it hits the return statement. But you do the whole thing here, and there's one that's kind of odd. It has a long name, R flags. Okay. Download one of my programs. If I've done it right, I have these happening right after the colon, after the name of the function, then come all of these. Now comes your chance to shine and put your algorithm. Your actual coding of the application starts here. And I'm trying to remember, the first thing it does is to output a welcome message, I think. But at this point, we're going to program in blocks. A block usually corresponds to a single line in C++, but assembly will frequently need a block of 5 or 6 statements to accomplish the same thing. So let's put a heading statement on each block. Block that welcomes the user. You look at the sample dialogue in the assignment one instructions, it'll show you what's to happen first. Okay, that means we want to say something nice. We need an initialized string that has that message in it. Okay, so this is I have to go back to segment data to put that. And I don't want to mess up the code here. So off on the side here, there's a string, welcome. There, okay. So we assume that's already in place up above. And we should have one more string form, which is percent lowercase s 0. Okay. Let's do it. A block. Move RAX 0. The meaning of RAX with a 0 says that the number of floating point registers involved in this block is 0. Sometimes you can get away with omitting that, but it's safer to let's include it. Yeah. Number of floats involved in this block is 0. Okay. RDI. RDI is the first passing register for the data that we're working with. And that will be string form. Okay. There's a special sequence to registers. This one takes if printf were in assembly, if printf were in C++, the first parameter is a percent something, S. And the second parameter is the actual string. Okay, so we're going to match it up. This will be RDI and this will be RSI. There's the first one. There's the second one. What was the name of it? Welcome. And I think we're done here. Okay, that's a block. Okay, and then you leave a blank line here to separate the next block away from the block that was just finished.
Pass with the same wall before the printf at the end.
Oh, that's a call. CALL. Okay, no problem. Okay, so sometimes I forget where the camera is. I think it lines up better there. Okay, we need somewhere it says enter your first and last name. So, okay. Let's use fgets for that one. Fgets reads, it's like string length. There's whoever reads strings. Okay. Fgets in C++ is the string where it's going to go, destination, comma, max size, and from where? Where? Okay, we have 3 parameters as part of the block that sets up the call to fgets. Okay, so I leave a blank line and then I say a block that will input full name. Okay. That there's no floating point numbers involved in inputting a name. Let's mark it down as 0. Okay. Now okay. The destination, if you're inputting a string data, you need an array that's not uninitialized that comes from the BSS segment. It's a clear candidate for BSS. Okay, so I need to BSS says username reserve bytes. How many can be in a name? I bet 24. Okay, so move RDI username. That's the first parameter required. The next is how many? RSI. This was declared at 24, and I think I forget the rule. You're supposed to leave 1 or 2 bytes for the new line, for the end of line, the null character. We have to look that up. I'm going to put 22 here. That means the function is going to read up to 22 characters, and if your name is longer than that, it cuts it off and doesn't accept anymore. Okay, and then the third one is where's it coming from? In C++, sometimes you're reading strings from files and you put a file name here, but we want to put the keyboard's name here, which is generally known as stdin. And if my memory serves me right, you have to dereference this. Okay. That's keyboard. BOARD. Okay. And that's the 3 required parameters for calling fgets. I think we got that pretty good. Well, we're going faster than that previous class. Are you all catching this? Okay. Okay. If you're recording it, you can play back the tape and play back the video and get it that way. Oh, but AI will give you a really good description of what's happening, but it doesn't have the image pictures. All right. fgets. Now, fgets has an issue. We have to correct for it. I guess this is time to learn this now. You'll need it in that first program. When you input your name into the input buffer, John space Brown. You press enter key. The enter key ends up inside the buffer. See if I can explain this right. The enter key goes inside the buffer. fgets will, oh yeah, it's coming back to me. fgets is going to read this thing. The enter key is like the new line character. Okay, I bet it has the same ASCII value 10 that new line has. So F takes it out of the input buffer and puts it in our example, it puts it into username. JOHNBROWN. Enter key new. That's what you get. Now, if you output that, you know what's happening. John, if you want to output the sentence, John Brown lives in Fullerton, it's going to go John Brown, new line, lives in Fullerton because of that one. That's the nuisance character. The nature of fgets is to read the input buffer until it reaches the new line character or it reaches the max. The max is the 22, but suppose someone has a short name, Bill, okay? Then it will read Bill, new line, and then append a null by itself. That null is put in there by fgets just because strings are supposed to have nulls. But for the end user, that's probably unwanted. We have to get rid of it in assembly. Now, how do you do that? If we call string length, what's it going to count? It's going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's going to count 11 characters. Okay. But the new line character is in arrays, we start from 0. It's in position 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's in array slot 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. It never, string length that never counts the null character. It counts everything up to, but not including the null character. Okay, so what we want to do is put the null character where new line is and override it, and that becomes the logical end of the string. Can we do this? I don't know what new. Okay, we got it. Okay. So get string length. Okay. I'm setting a block up to call string length. Move RDI username. And call strlen. Okay. Comment. The answer is in RAX. Okay. So I got an answer. In this picture, it would be what's the length of this thing? String length is 11. Okay. And now 11 sits in RAX storage. And then we take username. Let's see if this works. The username plus R15 minus 1, comma 0. We gotta prove it, verify that that works. Okay. So username is really just a memory address. All arrays that their name is just mnemonic for humans to see that, to have something to hang on to, which is a memory address. So it's the memory address of John here, and we add to it 11. Okay, so 11 would take us to, I don't know how to do this. 11 would take us to here. We're at 0, we add 11. This is 11, but it subtracts 1, and so it positions itself here. And then this 0 comes in, that's a dereference to the actual storage. This is an address is like a 10-digit number. And you add the 11 bytes to it. We carry us out in this picture to here, and we subtract 1, backs us up to here, and then we write a 0, the null character, at that position. And now username looks like is John Brown 00. String length will read up to the first 0 it finds and not included. So it will have an actual count of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 will be the string length now. It's been reduced by 1 from what it used to be. And the new line character is out of there. Yeah. So this is the end of inputting full name. So I'll mark it as end of input full name. Okay. Wasn't that easy? Assembly generally generates 6 to 10 lines of code per one C++ line. This could have been done in C++ with a single line of a function call, like here. F gets destination would be username, comma, max size would have been 22. And I think you still have to use standard in to reference the keyboard, but so be it. That one line, well, we got it done over here, so you know how to do it. Okay. Oh, then it goes on. Your assignment goes on to ask you to input the sides of two sides of a triangle, and eventually the angle in between. I think, what's our clock like? Most lectures, most class meetings, I lecture up till 10:50, but this is a special day, so you can get started on the assignment. When you go home today, you pull it out and say, assembly is my favorite subject. I'll do that one first, and American history will come second. Okay, so I'll end with inputting a number. Okay. In a number, how to, we need to make a block. Whereas in C++, it would be CIN into float number. This is going to turn into 5 or 6 statements when the assembly does it. Assembly instructions are atomic. They're interacting with electricity, and it has to be down to the fundamental part that can't be decomposed any further. When we say move RAX 15. Well, first of all, the assembler has translated 15 into binary. A whole bunch of zeros and 1, 1, 1, 1. 4 ones is 15 in binary. So it's translated into that, but then it means get electricity that has 4 positive charges and a lot of negative, or no charges is better description, and move it into this register, which has 64 slots. The register is like an array, but it's not changeable in size. There's 64 slots, and in assembly, we commonly reference them from the right side to the left. So this would be number 63rd bit of electricity over here. We have to charge these with positives, 1, 1, 1, and these are negative electricities. Okay. So it breaks down that each assembly instruction is one electrical move, and whereas in C++, one instruction is a dozen other moves. All right, so how to input a float number? Float numbers need their format. So back in the segment data, we need float form. BB% LF. Let's see, do we need anything else? Okay. Let's do it. Block to read one float from keyboard. Actually, the technical word would say it's already come from the keyboard into the input buffer, but we're going to get it from the input buffer into our program. Now, I'm going to use scanf. The scanf is great for numbers. It's not very great for strings because it stops on white space. So let's plan ahead and move RAX 1. One float number is going to be involved in the following. Move RDI. Move is a copy operation. They should have called it copy long ago, but it's too late to change it now. Copy the address of float form into RDI. RSI needs to know the destination, but scanf, the second parameter has to be a pointer. I don't have space to show me. I don't want to mess this up. Scanf percent LF float ampersand float number. If scanf is used in a C or C++ program, it takes this form, and you notice this one is a pointer. It's somewhere leading to memory. It's an address leading to memory. The easiest way to do it is to put the ampersand in front of the float declared variable. Okay, we have to do the same thing. So where are we going to get a pointer from? We get it from the stack. Did we do the stack here? Scanning through all the stuff. No, we didn't. Oh, when?
Got it drawn from the previous book.
Is that what I had? Okay, let's do it right now. You'll have enough tools to make big progress on this assignment. Okay, so back to architecture. There's a CPU. We know what that is. There's a built-in stack in every machine that is accessible from source code. In an assembly, it's customary to draw the stack upside down. So here it is. This is bottom. This is top down here. And technically, you're supposed to draw it with 1 byte per item on here. But it would make the stack run off the edge of this page. These are going to be quad words. So there's 8 bytes on a line here. I hope there's 8 there. And then the next one has 8 and 8 and 8. Okay, so then there's an address for every byte, especially those on this side. That one in the corner is we'll have the address, that byte is the address of the top of the stack, right? How can I make it stand out? Yes, sorry. Thank you. Okay. That corner is 1 byte, has 8 bits inside. It's in memory, and it has its own address. Its address is always stored in the register RSP. So it's some big ugly number. It's in decimal, it's 10 digits long, and that's the top of the stack. Okay. And the bottom, we rarely deal with it. It's somewhere far away in higher addresses. So the addressing runs from low up the page to high on the page. I can't even write one. It's I won't even try. This guy's a pointer. It points to that one. If we push a quad word of junk onto here, then this one moves automatically to point to this corner over here. RSP gets bumped down there or something. Yeah. Then it's pointing to vacant space. That's where we're going to put our number. We're going to use push junk here. I'm actually going to push all zeros. RSP will move up here. It'll be a pointer to this corner. And then we'll use that one for the scanf function. Okay. So 0 is by itself is ambiguous. 0, we don't know if it's represented by 16 bits, 32 bits, or 64 bits. It could be any one of those, but this is called a qualifier. It qualifies that this 0 that I'm looking at, pointing to, is a 64-bit 0. So it's composed of 64 tiny negative charges of electricity. I can't write all 64, but you get the idea. And in picture form, it's added this to the bottom of the top is the bottom. You put all these little zeros here. Each little square is 8 bits, and I have 8 bits across. 8 times 8 is 64. We put 64 little zeros across the top of the stack. Okay, now RSI is always the second passing parameter. RDI is always when you're talking of integers. RDI is always first, RSI is always second. If you go back and look at the old previous ones, it follows that pattern. That's now going to be made to point to the top of the stack. We have 2 pointers to the top of the stack. But scanf only pays attention to the RSI. We programmers have access to both of them if we needed both of them. I think we're ready to go. So we say call scanf. And you put in from the keyboard a number like 33.72, some number that first goes into an input buffer, and then scanf goes to the input buffer and reads float data until it comes to something in the buffer that's not float data. If it came to a white space, it would stop reading there. Okay. What does it do with dots? I'm pretty sure it's in the software of scanf that if you had just input 33 and then W over here, it finds that non-numeric. It reads 33 as if they're, and it artificially puts a dot there. It doesn't reject it. Okay. Most float numbers come like this. Okay, so that's sitting on top of the stack. It's I'll redraw it. Top of the stack is when we say 33.72. RSP is here. That's okay. It does what it was supposed to, but we can't perform addition and multiplication and division with numbers sitting in the stack. It has to be in a register. So let's finish the job. I'll pick something, 9, comma, R, S, T. So that means follow the pointer to the top of the stack, dereference it, and then you have the actual data stored there, and copy that data into a register number 9. There's a move that's spelled MOV it's an action on integers, general purpose registers. A move that ends in SD is an action on float numbers. This is part of, remember that component called SSE? And this is part of the component general purpose registers. So this is a copy from the top of the stack, a whole quad word, into the register XMM number 9. We could have put it into any one of the 16, but 9 is okay. Then we're almost done. This stack has an extra quad word that wasn't there before this block started. It's like when you have a picnic in the park and you have all your trash at the end of the day, you're supposed to pick up your own trash and put it in the trash can. This is the trash left over from the block over here that was reading one number. We got to clean up the trash. And now we're done. That puts the stack back in the condition that it was before this block started. And it's actually a reverse of this one. Okay. We're done. Okay, I think I need to stop. I'll pause there. There's some other stuff to discuss about that assignment, but you can do 90% of it already now. Just charge ahead. Then tell me, Hunt, When do we meet next? It's next Monday. Yeah. So tell me what problems you ran into, what works, what doesn't work. I think I gave you lots of tools to apply. You can start out by making the driver program. That's an easy first step. And make sure it works. And then I would build this by incremental development, incidentally. I don't have it in front of me, but in the handout, there's a dialogue. I kind of remember it's part of it. It's there's welcome to triangles by let's see. Okay, so make a program that outputs one line of the dialogue, the introductory one, and look at it and make it error free. You got to debug the compiler. Make sure there's no compiler errors in the driver and no assembly errors in the triangle function. Okay. But that's all it does. And then add the next line to it. Look at the dialogue and see what it's asking for. It might be a prompt message that says, please enter your first and last name. Okay, make that happen. Please enter first and last name. If you go for the whole stew at one time, you'll be overwhelmed by the mess that you've created. The error messages will fill pages of stuff. Okay. It looks so daunting. Okay. But then go for this. Your goal is to say, output the one phrase, please enter first and last name. And make that run. And then you go to where you enter the name. Right. Okay. We did that with fgifs. You can copy my code and you can put it in there and make that run. All it does is say welcome, and it says please enter first last name, and it accepts your name, and then it gracefully terminates, and you'll be making incremental progress, and that's the way I do it myself. Okay. Now, software engineering will tell you have to draw lots of diagrams and lots of checks on what you're doing, and they're right. But here, we're all learners, and this is the best way to get started initially on assignment like number one. Okay. What's your questions, class? Want to post them? You want me to show a slide again? You could just keep building this until you had the whole thing working. That's what we're after. Okay, like I said, next class meeting, I'm going to cut myself off at exactly 10:50. Lectures are supposed to be 1 hour, and open office is supposed to be 1 hour, and I'll adhere to that more closely in the future. But today was special so that you could get started on your first assignment. Okay. Eventually, I'll give you chapter numbers in the book where we're working from, but that's not ready yet. No question. You have a long weekend. No trips to Disneyland, no fun. You can start programming. Isn't that great? Okay, have a great day, everybody. It's all done.
What if we do our work in
You'll have better willpower than I could do. If I was in Disney, I couldn't focus. Oh, it's not, yeah.